Alex Lawrence Barkley at AutoSens Detroit, our inaugural show here in the US. I'm here with Benoit from Kalray, talking about Manycore processors. Benoit, thank you very much for joining us here in Pontiac, just outside Detroit. How are you finding your first AutoSens?
Yes, I like it very much, and I've learned a lot about what other companies are doing in that space. We are a fabless chip company, and we manufacture many core processors which have hundreds of cores, but these are real cores, not CUDA core or specialized core. And our point is that we can run efficiently many functions of autonomous driving, especially the perception function, and consolidate all those functions running on the same processor. So this is basically the demonstration we have here, computer vision function, and most interestingly, deep learning functions.
Okay, let's have a quick look at what's on screen here. We've got 16 blocks on the core. What does each one of those blocks represent?
So each block is a cluster of 16 cores, because in fact we have 256 application cores, but we cluster them into units of 16 cores. And this 16 core cluster is a basic unit of execution onto which we distribute the function. So a function, like in computer vision, can take one or more compute cluster, and the same for the deep learning inference functions. You could compare to a GPU, a graphical processing unit. The graphical units, they have what they call a streaming multiprocessor, and they have several of them. And the idea is that each such a unit has a bunch of core and a local memory. And exploitation of the local memory inside the cluster, remember we have 16 of them, is the key to high performance, low energy, and most importantly, time predictability. And this is what you need when you want to guarantee your car will brake or react in real time, and you must be sure about the timing response.
So actually having a multi-core processor reduces the time lag between moving signals between chips as well, not just about how they process data.
Exactly. The local memory gives you the low energy and the low latency you need for real-time operations.
So you've got a 256 core processor doing many different tasks. How much energy is it actually using at any time?
So each individual core, we measure it's 10 times as energy efficient as a regular ARM core, for instance. But when you put 100 of them, you get in a power range around 10 to 20 watts today. And for the next generation chip will be below 10 watts, and 10 watts overall for 100 of cores is what you want in embedded system, in particular autonomous cars.
On one of these chips, can you give us a comparison as to how powerful each one of these cores is in comparison to a normal desktop computer?
I would say 16 of that core, 16 cores, that is one compute cluster on our machine, are equivalent to one Intel CPU.
We've got a CNN running with a camera here that's wired up to one of the Kalray's chips, and I'm just going to point it down to the pen that I popped there earlier, and it's recognizing that straight away. You can see on the screen moving over, there's also a little espresso cup there, and it's recognizing that straight away. Coffee mug, cup, measuring cup, espresso. I mean, all of those could be right, but obviously nice and close up. As it's got a good idea of what it is, you can see straight away it's stabilized because the camera image is stabilized. This coffee mug, but it's updating so quickly at 50 frames a second, operating very effectively. So tell us more about that particular demo.
Yes, so this particular demo is that we're running a pre-trained Google Net neural network, and we use a Caffe description, which is a standard framework. So
Caffe, that's open source, right?
Yes, it's open source from Berkeley, and that's a reference in open source CNN framework. So we just take the standard description of the Google Net CNN. We take the training, which is done offline, because in an embedded system you do the inference part and you do the training offline. And we demonstrate that with unchanged Google Net, we are running over 60 frames per second, which is almost twice what you get on a GPU of the same technology. So we demonstrate here that using a CPU-based Manycore processor with local memories, you in fact outperform by a large margin GPU, which are supposedly the best machine for neural network.
That's really exciting stuff. And if you want to find out more about the 256 core and their other processors, Kalray have just released a press release. Have a look at their website, and you can find out more about that online. In the meantime, Benoit, thank you very much for joining us at AutoSens Detroit, and we'll hope to see you next year.
My pleasure.